Hi friends, success comes from relentless effort. A rectangular aquarium is inside a car. From rest, the car accelerates forward. Now, we're asked to find the angle of inclination of the water surface. Initially, the car isn't moving. The water surface is parallel to the ground. This means the water surface in the aquarium forms no angle at all. Shortly after, the car accelerates. Some of the fluid is pushed back. The back of the aquarium holds more water than the front. Because it's incompressible, the water surface is inclined. Let's assume that angle is theta. This is the angle we want to calculate. How do we find this angle? It's simple. Inside the aquarium is a fluid parcel. The fluid parcel is shaped like a tube. To identify it, the left end is point 1, and the right end is point 2. The cross-sectional area at both points is the same, therefore it's a tube. The hydrostatic pressure at point 1 is different from the hydrostatic pressure at point 2 because the fluid depths at the 2 points are different. The hydrostatic pressure at point 1 is ρgh1. The hydrostatic pressure at point 2 is ρgh2. When a car accelerates, the resultant force acting on the fluid parcel, F, is equal to the mass of the fluid parcel times the car's acceleration. Since it's moving horizontally, the acceleration is ax. We don't know the mass of the fluid parcel. What we know is that the density of the fluid is constant because it is incompressible, and the size of the fluid parcel. How about writing the mass of the fluid parcel as ρal, since the cross-sectional area of the tube is A and its length is L? For the force, it's the resultant force acting on the right and left sides of the tube. Force is the pressure acting on a surface times the cross-sectional area of the surface. The values of P1 and P2 can be obtained from the previous hydrostatic pressure equation. The value of ρ can be crossed out. Note this, h1 minus h2 is the height of a right triangle. The ratio of h1 minus h2 to L is simply the tangent of theta. Write this equation like this. Isn't this value the tangent of theta? So, the tangent of theta is the acceleration of the car divided by the acceleration due to gravity. In our problem, the car's acceleration is 5 meters per second, and the acceleration due to gravity is 10 meters per second squared. Theta is the arctangent of 0.5, or 26.6 degrees. This is the angle of inclination of the water's surface immediately after the car accelerates. Happy learning, everyone!